might be like an easy fix right now. So talk to your neighbor for a second about something maybe you had confusion on. So take a minute right now, talk to the people around you.
I sat there like 15 minutes. I was just like, I don't know how to Oh yeah.
All right, everybody got a graphing worksheet, yes? Okay, because I have like 3 extras, so it's kind of weird. Okay. All right, let's come back up here together. You guys are doing great helping each other, but I'm just going to move our process along. 3 was the first one I kind of heard a cry for, actually no, 2 was the one I heard a cry for help on. Someone asked me about 2, but really you just had to have the half-life equation for 2, so 1 over k initial concentration. They gave you the time and they gave you the initial, so to solve for k, you just had to rearrange the equation, and this was in minutes, so in the end you got 0.00211 per molar minute since you divided by molar. Thumbs up, can we move on from 2? Okay. 3, it gave you slightly different starting points, so it gave you moles and liters, or milliliters, so therefore you had to find your own molarity. You cannot plug moles into these concentrations, you have to get to molarity first. So you had the 5 or 0.5 moles over 500 milliliters, which is 0.5 liters. So your initial concentration was 1 molar. And then over the course of time, it changed to some unknown concentration that you didn't know. But you were given the K and the time. The only thing that was weird about this was that K was in per second, and the time given to you initially were 5 minutes. So you did have to convert that to seconds first. So who did that? Beautiful. So units matter, right? Make sure you're in your units. Once you go and eventually find ln of A, ln of A is negative 1.461. So to offset ln, so opposite of ln is e. So you raise it to e to that power, and so in the end you get the molarity to be 0.232 molar. But it did not ask for molarity; it asked for moles. So given the fact that it never told you the volume change to that container, all you do is you multiply molarity, so moles per liter, by the liters given, so the milliliters in that case. Liters cancel, and you end up getting 0.116 moles. So that's the only piece at the end that was just old news. We already knew how to get from molarity to moles, except we just didn't do it yesterday. Thumbs up on 3. All right, now 5, right? 5 was the the one I put on the board. Oh, I didn't do 3B. Sorry. This question, I forgot how it was phrased. It must have asked for the time it needed to drop from.
The quantity of.
Sorry, I'm on 3B.
To drop 1 mole.
To drop to what? To drop what?
To drop 0.1 mole.
0.1. So to drop 0.1 moles?
Yes.
Okay, so if it was dropping 2.1 moles, it was still in that volume given, so it's technically asking to drop to 0.1 moles over 0.5 liters, so that was 0.2 molarity. So it's asking for that to be your final concentration. It was phrased differently, but that's your final concentration. Plugging that concentration in along with the initial concentration they gave you, still using the same K value, that whole time, the time was what the question was regarding, so in the end, once you calculate, you should get 330 seconds. Okay, now 5. I just want to make sure I talked about B part of that. So it's nice when they give you the order, right? So the first thing they gave you was first order. Immediately you knew the half-life equation for first order, which was 0.693, also known as what up here? ln of k, right? Ln of 2 over k. And they told you the half-life was 1,620 years. They also told you the k. So you had to find the percent that changed over a certain amount of time. So basically, knowing that this first order, you already know the integrated rate law equation. You know the k, the 100 years that was passing, and that makes sense because you have K in years and time in years, so those will cancel. You were given the initial concentration of 1 molar. So plugging in everything, your job was to find LNFA final, which was in the end going to give us the final molarity. So in the end, it went from initial 1 molar to a final of 0.958 molar. So not much changed. So your job is to figure out how much of the original was like left, I think that's how this was phrased. So final over initial gives you the fact that you actually only had very little that reacted, so 95.8% is remaining. Are we good here? Okay, and then lastly, 8. I heard cars for help on 8. 6. Okay, let me come right back to that. So 8, they told you initial concentration of 0.086 molar. The time, second order, and the K value, you have everything you need to plug into the second order integrated rate law. Plugging in information very carefully, then you're eventually solve for 1/8 final. So you'll notice the seconds cancel, and then this is like nothing over molarity plus nothing over molarity. So you end up with nothing over molarity, or number over molarity. So your final concentration, once you kind of solve for that, should be 0.034. So 0.034 is your final. And then I think you guys probably were okay with that. You just plug the numbers in. It's not too tricky here. But solving for the half-life is the secondary question. So you had 1/K times initial concentration. That's your half-life equation for second order. Plugging in the... Did they give you this concentration? Yeah. 0.072. Okay. I usually can figure out my questions from Harvard. So they gave you an initial concentration of 0.072. You had the same K value because it's a constant. So when you divide, you get 17 seconds for your half-life. And then secondarily, they give you a new initial concentration, plug the same thing in, and solve for the second half-life. So this is second order, right? What do we know about half-lives, how they are changed in the course of the second order reaction? Depends on the concentration initial, and as I decrease the concentration initial, what should happen to the half-life time? It gets longer, right? So we said actually it like almost doubled itself every time the concentration went down by half. So sequentially the half-lives get longer, and we see evidence of this here, 17 to 23 seconds. Okay? And then one more. 6, I heard. So you're solving for T1/2, but you had to find K first because you were not given the K value, so you could not simply plug that into the half-life equation. Given the fact that 25%, I don't know if this was phrased this way. Was this one phrased as 75% decomposed? Okay, so if you're not given initial concentration, choose 1, and then the final would just be like the percentage that was still remaining. So 1 molar and then 75% reacted, so you're left with 25%, which is 0.25 molar. Plug those values in along with the time of 60 minutes. So make sure your K value is a positive value, and I cancel that out? Looks like I did. Yeah, that molarity is not there. There's an X to that. So it's 2.3 times 10 to the -2 minutes, or per minute. And then when you plug the K value into your half-life equation, you should get 30 minutes. Okay, who feels pretty good about integrated rate laws? Still on the fence of like maybe with the half-life side of things, but if you have the givens and you have the order, you plug that thing in and you're done. As long as you're not making stupid mistakes with like natural log or something like that, you're good. Okay? All right, so let's check out the requirements I need for the lab real fast. A couple of you guys did a fantastic job. I made some comments. I will go back to that number 4 in a second. I made some comments and I just want to make sure everybody saw those things I need. One, make sure like you're annotating this as you are working with me. Make sure you get your Beer's Law graph in there, okay? Leave a space for it. Put your linear regression line for that Beer's Law graph. I'll leave this up throughout the day, no worries. Once you get to part 2, you're gonna have like a table in your Logger Pro software, and it'll have like time and absorbance, because remember, we're using colorimeters, so we're not getting concentration off the bat. We have to find that ourselves. And this table will go on for eternity. Like it will be so long, because it depends on how frequently it's collecting data. You can have it collect 10 samples a second. Like you can get that amount of data. Now we don't really need that amount of data, but you do need to have a very frequent data collection time. Like waiting a minute between samples or collection points, way too long. But you should be doing it a couple of seconds at a time. So if you have a huge data table, I only need 10 points from the data table. That's what I want in your Google Doc. Those are the 10 points that I want you to plot in your stat plot to do first order, second order, and zero order with. Okay? Good? So make sure you have that. You will be integrating in all three ways, all three integration types. So you will have to prove that you have linearity in one of them and not the other. So do make sure you have the R squared values, their graphs, and then their y equals mx plus b's there for support or for your justification of your conclusion. And then all your conclusion will be justified with your data. So do make sure you're referencing certain points of your data. Use the Logger Pro data collection modifications, which means that when you go into Logger Pro and hit data collection, you will have to modify it for like the length of time. So it might cut off after 60 seconds. Well, that may not be enough time for us. We'll have to modify that before we get started. Remember, a lot of you guys forgot to say prime your cuvettes. So what I mean by that is that your diluted solutions you're making, right? What do you do with it? Put a little bit in the cuvette. Shake, shake, shake. Do you want to touch it with your fingers? First of all, it will sting you, right? So put like a little piece of paraffin on top. Shake, 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 dump. So make like a waste beaker at the end. We'll kind of dispose of the waste at the very, very end. Do not pour it down the sink. Okay? All right. And then you take that sample out, put your real sample in that you would like to test with, and that's going to be priming. Something else with that. Oh, so whenever you're priming with part 2, which is the reaction between sodium hydroxide and CV, you have to be super fast. Okay? So how much have you? Most people didn't actually put down. Okay, like 2 people put down how much CV and sodium hydroxide they're going to use in part 2. Anybody want to tell me what they're going to use? Part 2. Let's just take a stab at it.
20 grams.
You're not getting on this. 5 milliliters of CV and 5 milliliters of NaOH. Okay, so you want to do a half split. You could do 1 milliliter of CV and 9 milliliters of NaOH. You could do a variation of that. Do not use the diluted versions of your CV. Use your stock, which was what molarity? 25 micromolar, right? So do use that, but it doesn't necessarily matter which combination you use, because you were tracking that initial concentration of CV, or sorry, initial absorbance, which you'll convert to concentration, and you're just tracking that change over time. It doesn't matter how you start. So just come up with a plan, and let's call it a day, okay? Now, what you're going to do is when you add these together, it's immediately going to start reacting. But you have to mix it, so add 1 plus 2, mix, grab a plastic pipette, put it in the cuvette, swish, 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 dump, grab the sample, put it in there, then put it in the colorimeter. Okay, you got that? Okay, so that's, you have to prime that first. Okay, so 1 plus 2 in a test tube, right? Mix, pipette to the cuvette, swish, 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 jump, pipette to the cuvette, test, run. That's got to be fast. Now, we're probably going to do that twice or 3 times because you're going to be slow, but it's all right, because it's going to react as soon as you get it in there. But again, that's like many people are going to probably be involved in that process. And then my last comment was that be sure that you're using the same cuvette, because there are slight differences in cuvettes, so we always want to try to eliminate that error from our experiments. And then, yeah, we did that. Okay, cool. If you would like a lab apron, I do have those. Like, you don't want to get CV on your shirt, or you can tie that your shirt with CV. Okay, let's go. Let's get Logger Pro stuff set up really fast, guys. The middle lab stations, I have a laptop here for you to get stuff up. That's my extra. That's my 7.
I don't see how this is based
Yeah.
So guys, listen as you get started. Listen. Do not start your Logger Pro, of course, until you get your dilutions made. Someone probably needs to get one person can work on getting Logger Pro set up and kind of manipulating the data collections so that you get the data you want. But everyone else is probably working on dilutions. Okay? So CD is in the human. CD is in human. I'll leave this report out like this. You give me a beat or I'll get you some CDs.
I think you said I did it.
Guys, the more glassware you put CB in, the more glassware you will be seeing at the end of this, so you know, beware. I have pipettes, plastic pipettes that I can track to the end if you want. Wait, did you guys calibrate this machine? You gotta blank it. Guys, you gotta blank it first.
Oh, that's the one.
Wait, hey, we're using 565, 635, right? 635. No.
I don't want to drug it.
That's it? Just like do these.
Alright, I'm just gonna call out a couple of instructions. Raise your hand if you're the Logger Pro person right now. Alright, I need a Logger Pro person on the computer right now. I'm gonna just make it simple. Everybody's on Logger Pro. As soon as you plugged your colorimeter in, it came up with transmittance. Right click on that red transmittance if you've not already. Okay, so we right click on transmittance and we now go to digital meter options. And we're gonna change that to observance, a little drop down menu. Now we're reading observance, and so make sure that when you go to data, go to experiment at the top. So my Logger Pro people, thank you. Experiment at the top, go to data collection. Down on the experiment options. Let's extend that to like 500 seconds, something longer, so that there's no issues. And let's collect samples every, 2 to 5 seconds, right? So make a choice. The more the merrier. Okay, so then hit done when you're done. Alright, so basically at this point, let's keep listening. Once we get to this this option, well, okay, before we get here, you all need to blank your machine. So when you take the that, the one that you've chosen, the chosen one, you're going to put DI water in it, and you're going to blank your machine. So the calibration button on the machine, it says cal, that's what you're going to be pushing until it stops blinking. So I'll go ahead and get that done now before we kind of get into the next. Guys, you don't get any more Kim wipes. You have like 1 or 2 for the whole lab. Don't you take all my Kim wipes. So I already have to buy more in November.
How many Sundays do we have?
We're gonna start with five.
Guys, please.
Who got the caramel? Did I misplace it? Really not that. Oh, so we're gonna. You guys can have it smaller.
The one that we get the 15, the one that we got is very close to the so we think there might be an error there. And look at the big double next error. So that we can do the action. So we can try to prepare a bunch of We're gonna put 25 seconds. I just added that in to give it some more. We technically don't use that.
This will not fit in the order.
You see half and half.
Oh, wait. Yeah, she said, apple shape, put prime shape. Okay, so you know.
Alright, soon we should be reacting, we should get into part 2, so, you know. You guys will join us.
Oh, we're only doing the 25?
Only did the dilutions so that you could do like calibration for your response ratio.
That's where we're going
Let's do that. Let's do that like 2 times 5 to 5 so that we make sure that we Oh, okay.
No, I think it was just a trick. I was something
Oh, right here.
Okay, I just like yeah, like actually, it's like it's been hanging with me for
FYI, you do have to collect on Logger Pro to get your time data. You have to collect. They don't just sit and look at it.
oh man,
Yeah?
So you want us to, you want us to send
It's up to you and your time interval, but you do need to go ahead and collect a plethora of data so you can pick your data. Okay?